Good morning, and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video I want us to just understand Pure Mathematics 2 second topic, and it's called coordinate geometry, and we've been looking at it for the last 1 week now, and I would want to explain example 11, which is on page 36. And this is quite an important example, and I want to be very categorical that students need to follow very closely because it has some very critical levels, and we are going to use all properties, including the properties between a tangent and a chord, a tangent and of course the radius, and so on and so forth. And in this one, we are told that a circle C has equation x minus 5 squared plus 1 plus 3 squared is equals to 10. The line L is a tangent to the circle and has the gradient of -3. Find two possible equations of L, giving your answer in the form y is equals to mx plus c. We have that information. At least we can tell the center of the circle. We have the gradient of the tangent, and of course we need to approach this question in levels. And let us first of all find out what we need. The first thing that we need, or we can tell, is the center of the circle. The center of the circle. The center of the circle, which is 5 minus 3. The second thing that we need to equip ourselves is the gradient of the diameter, because we need the diameter. If we have the gradient of the tangent, we need the gradient of the radius, because the tangent and the radius are perpendicular. And if the gradient of the tangent is -3, then the gradient of the diameter is a third, such that a third times -3 is going to give us -1. And of course, the next level we need is the equation of the diameter. That one we can get. The reason why we need the equation of the diameter, so that we can eventually substitute in the equation of the circle to get the corresponding or the coordinates of the point of intersection. So let us just have a diagram of what we think this question is telling us. We happen to have a circle here. That is the circle. We have a tangent whose gradient is -3, and we have the center of the circle, and we have the radius there, and the question is asking two possible equations of the line L or of the tangent. So it is very possible that we could have another parallel tangent on this other side with all the qualifications. Please note, this is the center 5 minus 3, and this tangent is supposed to be perpendicular to the diameter, and likewise we are supposed to have a diagram that looks like that. Now that we have the gradient of the diameter and it has to pass through the center, of course, let us go to finding the equation of the diameter. And of course, the equation of the diameter, we know that the change in y is equals to m change in x. The change in y is equals to the change in x. And therefore, if we may talk of this y general minus -3, which is +3, is equals to the gradient, which is a third, the gradient of the diameter, which we have realized to be a third, open the bracket, x minus 5, we can already tell that the equation of the diameter is y is equals to a third x minus 5 over 3 plus 3, which is because minus 5 divided by 3, yes, it's going to be minus 3, it's going to be minus 14 over 3, so minus 14 over 3. This happens to be the equation of the diameter. And before I move on, I need to explain something very crucial here. The equation of the diameter satisfies every point along the diameter, including this point and including this point. And you realize that this is where the diameter intersects with the circle. And the value of x for the diameter is the same value of x for the circle at the point of intersection. In other words, we have the equation of the diameter and we have the equation of the circle, which have to be solved simultaneously because at the point of intersection, both equations are equal. So we are going to have point A and you're going to have point B, whereby the circle, the diameter, and the tangent both have the same values of x and the same values of y. So solving this equation simultaneously, then we can talk about substituting this equation of the diameter into the equation of the circle. We will be getting the coordinates of this particular point. Therefore, x minus 5 squared plus, now y becomes a third x minus 14, a third x minus 14 over 3, of course, plus a 3 squared is equals to 10. If we collect the like terms there, we are going to talk about minus 14 over 3 plus 3, then it's minus 5 over 3. So we have x minus 5 squared plus minus a third x minus 5 over 3 squared is going to give us 10. The reason why we have done that way is so that we can substitute y to be left with only one unknown, and then once we have its value, then we can substitute in any of the equation to get the other. Expanding this, we definitely have something to do with the x squared. We are expanding now this minus 10x plus 25 plus 1 over 9x plus you are expanding this 1 over 9x squared minus 5 over 9 minus 10 over 9 minus 10 over 9x, and of course plus 25 over 9 to give us 10 at that particular point. Then we can say we have that equation, and that equation can now be solved by collecting the like terms. We can say x squared plus a ninth x, which is 1 over 9, which is 10 over 9x squared, 10 over 9x squared, minus 10x minus 10 over 9, that is minus 11 over 9. This is minus 10x minus 10 over 9. We can talk about minus 10 minus 10 over 9. We find it's minus 100 over 9x minus 100 over 9x, and of course we have plus 25 over 9 25 plus 25 divided by 9, and then we find this is 250 over 9 plus 250 over 9, which is equals to 10. As it were, you can see you can simply multiply everything by 9 and have 10x squared minus 100x plus 250 is equals to 90. And because it's tending to be a quadratic equation, we can already help it be by writing 10x squared minus 100x plus 250 minus 90, which is plus 160, is equals to 0. Dividing everything by 10, we have x squared minus 10x plus 16 is equals to 0. And then we get to the level of factorization, which two numbers we multiply, they give us 16, and the two numbers we add, they give us a minus 10. Both of them are negative, and definitely this is minus 8 and minus 2. So substituting the middle term, x squared minus 8x minus 2x plus 16 is 0. So x minus 8 minus 2, x minus 8 is equals to 0. At the end of the day, you realize that x is equals to 8 or x is equals to 2. So very true. It is possible that at this particular point, x is equals to 2. And at this point, x is equals to 8. Very possible. But then, when x is equals to 2, what is the value of y? So we say when x is equals to 2, y is equals to, we go to the original equation of y, which is a third x, which is now 2, minus 14 over 3. And y becomes 2 over 3 minus 14 over 3, which is minus 12 over 3, which is negative 4. So when x is equals to 2, y is negative 4. Those are the coordinates of this particular point, point A. Let's call it point A. When x is equals to 8, y becomes a third 8 minus 14 over 3, which is basically 8 over 3 minus 14 over 3, which is minus 6 over 3, which is negative 2. Again, these are the coordinates of point B, possibly, where x is 8 and y is minus 2. Now, at that particular point, it is important to note one thing. It is important to note one thing, that we have a point A, we have a point A with these coordinates, we have a point A with the coordinates 2 minus 40 minus 4, and we have point A with 8 minus minus 2. Never mind about the possibility of, but of course, it is possible that this is minus 4 and this is minus 2 because this is below this. Now, having reached there, or having said that, we need now to get, and we have the gradient of the tangent. We have the gradient of the tangent, which is negative 3, and it is possible that this one of them is passing through point 2 minus 4. What is then this equation? Of course, y minus minus 4 is equals to minus 3, which is the gradient, x minus 2. And with this, y is equals to minus 3x plus 6 minus 4. This is plus 6 minus 4. And definitely, we are going to have y is equals to minus 3x plus a 2. That is one possible equation of one particular tangent, and possibly this one because it's the one with the lower value of x. And therefore, the other one is the gradient of the other tangent remains negative 3, and it happens to be passing through 8 minus 2. So again, taking the general equation of y, the change in y minus minus 2 is equal to the gradient minus 3, x minus 8. Then expanding this, we have y plus 2 is equals to minus 3x plus 24. And therefore y is equals to minus 3x plus 24 minus 2, which is plus 22. So yes, that is it. We have two possible values or equations of the tangent. But of course, as I told you, this question is quite involving. We had to collect facts first, which we have used. But of importance, the property of diameter and the tangent has come in handy in assisting us. All right?